Welcome, everyone, to our students, their families and friends, faculty members, and other supporters of the Skaggs Graduate School for Chemical and Biological Sciences. This is a special day in which you have each played a critical role. I'm Phil Dawson, Dean of the program and Professor in the Department of Chemistry. This is our 31st commencement, and many of us were here back in 1993 to celebrate the graduation of our first student and the formal launch of this program designed to educate and train the next generation of scientists to be fearless in their approach to science. Many of the students who are graduating today will take the research tools that they have developed in Scripps Research labs and use them to build their own research programs, leading to remarkable discoveries throughout their careers. Others will explore entirely divergent paths and make impact in business, finance, government, communication. Regardless of their career path, dedication and excellence to independent thinking that we value at Scripps will serve them well as they leave to make their mark on the world. I wanted to take this opportunity to thank the community of generous donors who have empowered our graduating students to reach the milestones in their scientific careers. To date, 73 students in our doctoral program have been awarded endowed fellowships, funded through the generosity of the Skaggs family, the Alsum Foundation, individual donors. Countless others have been supported through annual scholarships and awards. In the class of 2023, 18 students, and nearly half of those graduating today, have received donor support. The philanthropy of our donors not only enables these students to focus on their research during their time on campus, but also the impact of this philanthropy will be reflected in the future accomplishments of these students. Thank you to each and every one of you in the audience, watching online, and here with us on stage, who've contributed towards helping our graduate students thrive during their time in the Skaggs Graduate School. So during this ceremony, the faculty will individually introduce the graduates and highlight their groundbreaking research. You will hear about students who develop chemical transformations that have the promise to open up new avenues in drug discovery. Other students will have made fundamental advances in our understanding of biological systems, such as those that underpin how we sense the environment or fight disease. Every year, I find these individual stories of creativity and perseverance deeply inspiring. While there are many metrics of success, publications are a primary way that we communicate our achievements to the outside world. I've just received data from the library, and I'm pleased to report that the 41 students graduating today have collectively published 179 manuscripts. So this is really an astonishing output, since I suspect many of our graduates are sitting on papers and waiting to get them out, right? So this is only just starting. The manuscripts were communicated to the world's most prestigious journals and will be highlighted by our faculty during their introductions. Another outstanding statistics is these papers, many of which have been only in press for a month or two, have been cited 4,653 times. So yeah, we can clap that. That's pretty good. So while it's important to publish, it's also important that someone actually reads the papers and learns something important from them. And when we publish our papers, we recognize important papers and things that inspired us by citing them. And one way that it's not perfect, but journals are sort of, judge themselves is by what's called the number of citations that they get within the first few years of publication. And they call that an impact factor. And top journals aim for around 10, maybe the glossy magazines up in the 20s. So I'm pleased to report that the graduation impact factor of the Journal of the Scripps class of 2023 is a stunning 25. So well done, everybody. So graduate school can be a period of extreme highs and lows. I would especially like to thank the graduate staff for their tireless efforts to facilitate every aspect of the graduate experience. Many of our staff are here with us today, and I hope that you take a minute to seek them out, as their dedication and support are really critical for everything that we do. So graduating students, please stand up. I'm honored to have the privilege of leading the graduate program at our institute. And as we will hear today, you're already changing the world for the better. Parents, You should be very proud. The Scripps community is grateful to have had the opportunity to guide your children through their scientific journey, as described in their remarkable theses. So students, we're here to celebrate your achievements. However, none of this would be possible without the support of the numerous friends and family, many of who are here today or online and joining us. So why don't you turn around and let's give them an applause. All right. So it's now my pleasure to introduce the President and CEO of Scripps, Pete Schultz.
Thanks, Phil. I want to add my welcome to the graduates, their families, friends, and to the faculty. We're here to celebrate the extraordinary achievements of the 2023 graduating class. This is the last class of the first century of Scripps' existence, so that also marks an occasion. To the parents of the graduates, my guess is when your son or daughter came to you and said, "I'm going to graduate school at Scripps," you said, "What's that?" And then you Googled it, and you said, "I didn't know you changed your interest to oceanography." Okay. So we really are one of the best kept secrets, but be assured your daughters and sons have really good judgment and taste. Just Scripps at the last count was actually ranked the top independent research institute in the United States. And the graduate program's been in the top 10, I think, for 15 or 20 years now. And a lot of that was made possible by the incredible work and intellect of our graduate students and postdocs. As Phil said, today you'll hear about the scientific accomplishments of each student during their graduate stay from their graduate mentor. And hopefully that'll give you an even deeper appreciation for the impact your sons and daughters have had in their graduate career. And I would maintain probably the most rewarding part of our job as faculty is to actually work with such an amazing group of bright young people and watch their growth during their graduate careers and watch their continued growth as they go into their independent careers in science, education, medicine, business, and law. And I myself have had the terrific privilege of having over 320 ex-graduate students and postdocs. And, you know, every 10 years we get together and have a big party for 3 days, okay, with a couple hundred people. And it really is the highlight of my academic career. And those ex-coworkers wind up not only being colleagues in science, they wind up being very good friends, and they actually wind up keeping you on your toes through a kind of unspoken friendly competition. There was one year we were recruiting graduate students, and when we bring out new potential graduate students, we host them at lunch. And so the faculty sit down with the prospective graduate students, and I turned to a really terrific woman, and I said, so what are your interests, and who are you interested in working with? And she looked at me and she said, well, when I came here, I was interested in you and Dave Liu, who happens to be an ex-student of mine at Harvard. And at first I thought I'd be interested in working for you, but now that I'm here, I think I want to work for somebody younger and more dynamic, okay? So my colleagues looked at me and they were like, okay, what's Pete going to say to this? And I didn't blink an eye. I looked at her and I said, well, you know, learning chemical biology in graduate school is a little like learning the force. who would you rather learn from, Luke Skywalker or Yoda? Okay. She wound up working for Dave. Okay. But anyway, my only advice to the graduating class is, as you get to be my age and you look back, I think the things you'll regret the most are the challenges that you didn't do, okay, not the ones that you did. So really, I think you've proven yourself. Always have confidence in yourself and your ability and your determination. That applies to almost every decision except becoming president of a major research institute, okay? So I think as we begin the ceremony, why doesn't everybody in the audience stand up and give the graduates a round of applause that they can hear it sulk, okay? Great. Thank you. Be seated. It's now my really special privilege to introduce our commencement speaker, John Diekman. John and I have known each other for some 35 years. We're great friends. We've collaborated on a lot of really exciting projects, and every now and then we've politely butted heads, okay? John received his undergrad. John grew up in Cincinnati, actually not too far from where I grew up. He received his undergraduate degree from Princeton and a PhD in chemistry from Stanford. He then went into what at the time was the fledgling biotech industry, okay? First at Zoicon, where he learned something about the states of matter and how you change solid matter into gaseous matter. And then he was president of Monoclonal Antibody, Inc. And you can tell, back in those days, you could actually name a company Monoclonal Antibody, Inc., okay? It was a long time ago. So I met John when we started Affymax. John was the president, and I was a founding scientific advisor. And John led Affymax, which was really the first company to pioneer combinatorial methods, diversity methods, and their use in drug discovery. And now those methods that John helped create are used in almost all the entire pharmaceutical industry to make new drugs. John then moved on to become chairman of the board of Affymetrix, which was the first company, the gene chip, to put a gene or many genes on a chip. And Affymetrix was really one of the first companies to usher in the age of genomics and the genomic revolution. From there, John founded Bay City Capital, and in 2002, he started his own venture firm, 5AM. And 5AM has $2 billion under management and has formed 100 companies. So John has played a huge role in helping to translate the discoveries made at places like Scripps into drugs that impact many millions around the world. John's also publicly minded and gives back. He's been on the Princeton board. He was on the board of Caltech. And most importantly, he's been chairman of the board of Scripps twice. The first time from 1998 to 2003, and now from 2018 to the present. Speaking for all of us at Scripps, we're enormously thankful to John for not only his commitment to the Institute, but his insights, sage advice, and also his and Susie's wonderful generosity. So with that, I'll introduce John.
Thank you, Pete. Very kind. When you get to be my age, there's a lot to talk about in introducing people. I want to add my congratulations to the students and their family. Terrific, well done. I thought I'd reflect on just 3 personal experiences. The first 2 may have, I hope, some relevance to the students as they move on to their next career. Nothing earth-shattering, but just some thoughts. And the third talks a little bit about how I became acquainted with Scripps and some current thoughts about Scripps. The personal experiences, the first one really had to do with mentorship, and I tell you about it only because I hope as you move on, people less experienced, younger, want some help, some advice, please be a mentor, and if you see a good mentor, jump on it. My experience happened when I was right where you are today. As Pete said, I got a PhD in chemistry at Stanford. I did it in about 3 years and a couple months, and I was the first student in my class to graduate. So I wrongfully thought I was really smart. My life dream was to be a professor of chemistry, and I had already initiated a few discussions with universities talking about junior faculty levels. Right after my oral exams, I sat down with my advisor, who became, in his lifetime, an incredible mentor, and said, I'd like to talk to you about these conversations. I said, well, I want to talk to you right now. Okay, so we go to his office. He says, truncate those discussions with universities. He said, you've got to really spend more time, do a postdoc, and do more. And I said, why? He said, well, first of all, you're a very impatient person. The junior faculty, getting grants to run a lab is really hard. You get turned down a lot. It takes a long time to get where you want to get. It'll drive you nuts. He said, more importantly, you're very ambitious. You'll want to be one of the best in your field. And frankly, that requires defining some areas that you can do what others haven't, or that you can do better, being enormously creative. And he said, you've got a postdoc and develop some of those skills. Of course, my reaction was, this isn't good news. But when I went home and thought about it that night, I thought, this is really fantastic. He's willing to push me so much, but then turn around and critique where I am and tell me how to do some things that maybe aren't my plans. I came in the next day, chatted with him again. He said, what do you think? I said, I want to thank you. I agree that I really should postdoc and do more. And right away he interrupted me. He thought I was impatient. Right away he interrupted me and said, you thought about where you want to postdoc? And I said, I have. And he said, where? I said, Australia. He says, Australia? Why do you want to postdoc in Australia? I don't know what I told him, but he accepted it. What I was thinking was, I want to get as far away from here as possible. With that, he reaches back, picks up the phone. You used to have phones you held to your ear. He's poking it a lot, so I knew it was an international call. I could hear the other person answering, and my advisor named Carl said, hello, Arthur, Carl here. What can I do for you, Carl? They had a little chit-chat. And what can I do for you, Carl? He said, I have an outstanding student who wants to postdoc with you. I'm going, I don't even know who Arthur is. And it's dumbfounded me. The more I listened to the conversation, I realized, indeed, he was an amazing chemist. He even had a reaction named after him. When's he available? Carl said, he's available now. He's finished. He said, well, that works well. I have a room in my lab. He said, connect me and we'll work out the logistics. But Carl, before we do this, one question. Who's paying for him? And Carl said, Syntex Corporation will provide him a postgraduate fellowship. I'll come back to Syntex. I was off to Australia with my wife. I've never had so much fun. I have some lifetime friends. Just a very special part of my career. So mentoring, help out and help others and look for mentors. Second thing I want to talk about is entrepreneurship. All of you are familiar with that. I mentioned Syntex Corporation. It was founded by 3 gentlemen. It's a little Mexican company that did superb steroid chemistry, anti-inflammatory chemistry. They moved it to Palo Alto. It grew to be the largest pharma company west of the Mississippi and is now part of Roche. But one of those 3 people, aside from Carl, who founded Syntax was a man named Alex Zaffaroni. Alex was a soft-spoken man of Italian descent, grew up in Uruguay, immigrated to the United States and got his PhD from Rochester. Incidentally, he turned Harvard down because he wanted to work on his own project and not his professor's project, and it worked. Alex founded 7 or 8 companies, all of which were very successful. He's a very elegant man. He always wore beautiful Italian suits, looked like he came out of an Italian fashion magazine, but he was just a genius entrepreneur. One day, Alex calls me. John, now I'll cut it short here for you, Pete, because you've already mentioned something. He said, I want to start a new company. I'd like you to think about being on the board. Great. Come up and see me. I did. And he went through the, we're in Silicon Valley. You look at the semiconductor industry growing like mad using parallel processing, multiplexing. Why can't we do that in drug discovery? And of course, that led to what Pete already told you, combinatorial chemistry company, Affymax. And the great thing about being on the board and being part of management, Alex said, you're not going to have to worry about raising money. I'm going to put my money in, and when it's successful, we'll go public. So I was like, oh boy, that's a good deal. Anyway, it was successful. It was eventually acquired by GSK. And the story that Pete mentioned was kind of funny. He said, before I start this company, you have to understand how I start companies. I do it by signing up 3 outstanding advisors in different fields, and I'm not there yet. But I will be in 2 or 3 weeks, and once we have the advisors, then we'll start the company. So I'll call you in a couple of weeks. 1 week, no call. 2 weeks, no call. 3 weeks, no call. I thought he must be checking references because I'm not going to hear from him. And he called and said, okay, we're there. And I said, well, who are your advisors? So you have a couple of Nobel laureates, Paul Berg and Josh Lederberg, a wonderful pharmacologist from Stanford, Avram Goldstein. And he said, I've been trying to get this guy from Berkeley to join up, and we finally did. Who is it? Peter. So it's Peter Schultz. So that's how we all got together at Affymax, Affymetrics. The whole point of that is don't be afraid to be an entrepreneur. Whether you're an academic, whether you're a nonprofit, it's a lot of fun. You're going to fail, but if you fail, fail quickly and do it again. So, now the final thing I wanted to talk about was to make a few comments about Scripps. One day Alex came to my office and said, what do you know about Scripps? Northern California, pollen hay fever. What do you know about Scripps? I said, well, I know great science. It's in San Diego. He said, well, I'd like you to go down and talk to Richard Lerner. I've been spending a lot of time there. And do the same. And I said, well, I'd love to talk to Lerner. I know he's an outstanding scientist. I'd love to know more about Scripps. So I went down and spent 4 or 5 hours with Richard. And it was just an incredible time. Richard went through what we're trying to accomplish here. And eventually he said, why did you call me down? He said, I'd like you to join the board. I said, why? He said, because Alex turned me down. So, I said, he did? He said, well, I know Alex will be philanthropic, but he told me, unless we're talking science, he hates boards. He falls asleep during audit committees, finance committees, licensing, and he said, it's embarrassing when somebody has to poke me to wake me up. So he says, Diekman likes that stuff. You know, he'd be helpful. I'll be standing behind him on the philanthropic side. And that was my engagement here, which has just been it's just a wonderful time. The one thing that Richard talked about was the graduate school and how important it was to have a stellar graduate school. And I think that's worked. We're in the top 10 year after year after year in biology and chemistry. He introduced me to Bernie Galula, who likewise pushed the graduate school rightfully. And I know the current board management is in a situation now where we'd love to see every graduate student have a endowed graduate fellowship. And that's going to happen. Thanks to many of the faculty members here, thanks to a number of board members, the Skaggs family, we're well along on that pathway where the professors won't have to raise the money, the students won't have to raise the money, and there will be all endowed fellowships. The other thing that I wanted to mention, I'm going to just jump through these because I see I'm over my sell-by time. If you look at what's happened recently, just in the last couple of years. 2 approved drugs. Ozanimod from Hugh and Edward, thank you. Tafamidis, Jeff, thank you. Real contributions to the mRNA COVID vaccines, thank you, Andrew. And probably most special of all, in 2 years, 2 Nobel Prizes. Thank you, Barry. Thank you, Artem. We're really interested in attracting new senior and junior faculty, building new facilities. I think it's right over here, the new facility. I toured the parking lot the other day. It was a nice parking lot. You could get in and not ding somebody. And the thing I like most about the parking lot does not have a view. There's nothing worse than a parking lot with views. I'd say the other dramatic change in recent years that's really very interesting is bringing together Caliber and Scripps. Because now you can truly go from benchtop to bedside. You can do research in late stage preclinical, early stage clinical, and that brings together not only taking results from Scripps and pushing it farther, but bringing in whole new opportunities. And just looking the other day, work going on infectious diseases, malaria, HIV, tuberculosis, regenerative medicine, chronic diseases like fibrosis, NASH, obesity, and also a global health initiative. It's really pretty amazing what's going on at Scripps, how fast we've got there, how supportive the leadership has been and the board. And with that, all I'm going to say is a lot of that work was successful because of our grad students and postdocs. Go forward, be bold. Thank you.
Thanks, John. That was terrific. We're now going to start the conferral of the doctoral degrees. These candidates seated in front of me have completed all the requirements for the Doctor of Philosophy degrees. With the recommendation of the faculty of the graduate program at Scripps Research, I'm pleased to present them to you for conferring of the degree. And we'll proceed in the order indicated in the program, and Dr. Brenny will introduce the first candidate.
Hi, everyone. Congratulations to all the graduates, and thanks to all of you for being here, for your support of this year's candidates. So I have the pleasure of standing in for Race Andrabi to introduce Katharina Duker. So Katharina has been an exceptionally productive scientist. Her thesis work on mucosal and systemic immunity has resulted in several publications. She's first author on a paper recently in Nature Immunology, which is the top immunology journal in the world. And so I think Race and I, we've collaborated quite a bit over the last several years, have been extremely fortunate because Katharina is an outstanding scientist, but she has 2 really interesting and very valuable characteristics that we couldn't necessarily teach her. And one is that she's extremely motivated, has an outstanding work ethic that makes her stand out. And if you're standing out for that at Scripps, that's really saying something. And the second is that she's just a joy to work with. And so it makes people like me seek her out for collaborations. I think those 2 things are really big indicators of that your future is going to be filled with success. So Katharina, congratulations. Fantastic job.
My name is Dale Boger, and it's my pleasure to introduce our next graduate, Zichen Wu. Zichen's undergraduate career was impeccable, having received his BS, or Bachelor of Science degree from Tsinghua University in Beijing in 2017, working with Professor Wang, receiving their Outstanding Graduate Award and accomplishing work that resulted in a first author on Gavante Chem publication. As a result, I was excited when Zichen joined our program and even more thrilled when he elected to join our group. His efforts address two programs in our group, both of which many of you will recognize are near and dear to my heart. The first involved the exploration of peripheral modifications to vancomycin that improve antimicrobial potency independent of its native target, acting synergistically by introducing new mechanisms of action not expressed by vancomycin itself. His efforts were stunning, discovering and characterizing two new modifications, defining their structure-activity relationships, showing they are both structure and site-specific, characterizing their functional impact, defining a potential cell wall binding target, that is embedded teichoic acid in the cell membrane, and demonstrating that they act synergistically with other modifications we introduced to overcome vancomycin resistance. His modifications substantially increase not only antimicrobial potency beyond that of vancomycin itself, but even more importantly, their durability, that is, their lack of susceptibility to raising resistance as a consequence of the now multiple mechanisms of action. And then key members of the series proved to be potent, in vivo efficacious against a challenging multi-drug resistant and vancomycin resistant Staph aureus strain, representative of the pathogens we all fear will emerge in the general population. And combined, this produced vancomycin analogs even more powerful than what nature provided us with in vancomycin itself. A second area that Zichen addressed is our work on heterocyclic acidines, completely distinct area. Here he not only shaped our work on 1,2,3 triazines with detailed kinetic studies elucidating an unanticipated reaction mechanism responsible for its distinguishing reactions, but he also took on the synthesis of a previously unknown heterocyclic acidine, 1,2,3,5 tetrazine. And for those who in the audience may not recognize this, but it's remarkable in this day and age that no member of this compound class had ever been prepared, despite its simplicity and the importance of its isomer, 1,2,4,5 tetrazine, in synthesis and more recently in bioorthogonal chemistry. Zichen devised and successfully prepared the first member of this class, provided a thorough characterization of the new heterocycle, defined the scope of its reactions, conducted detailed mechanistic studies of its remarkably fast and efficient reactions, discovered reactivity both analogous to as well as orthogonal with its isomeric tetrazine, demonstrating their utility in chemistry. And ultimately, he developed a general synthesis for this class, making them available to the field and providing the foundation for their future uses in organic chemistry. His work led to 12 publications, 9 of them as first author. And finally, it's not just his science, but also his character that's impressive. He served as our group manager for more than 3 years, and I can tell you that's a challenging job. He handled this with grace and charm, cultivating a healthy environment for all to work in. The group, our equipment, the ordering, the lab's ability to run smoothly, even during the pandemic, was all due to his talents, skills, conscientious efforts, unselfish character, and willingness to work beyond expectations. Following his dissertation defense last August, which was bittersweet, that is, it was fantastic for Zichen because he received his degree, but it was crushing for us because we lost Zichen. Zichen joined Amgen as a research scientist. Congratulations, Zichen.
Hello. Hello. I'm Mike Bolong, and I have the immense pleasure of introducing our next graduate, Dr. Lara Ibrahim. So Lara was my first PhD student, and I have had the honor of co-mentoring her with Luke Wiseman over the last 5 years. So during her work here, she has made tremendous strides in characterizing the molecular mechanisms of the KEAP1 Nerve2 pathway, which serves as the cell's internal antioxidant system. So Laura has actually had a long time interest in antioxidants. Her 6th grade science project sought to understand the role of vitamin C in the eye, and it was aptly entitled, "Do You See Vitamin C?" So, needless to say, her work in the graduate program has really far surpassed her initial forays into scientific research. And to this end, Laura here has been incredibly productive, authoring 8 papers, 3 of which she is the first author. One of the key findings that I am particularly proud of is that she has identified that the citric acid cycle communicates to the KEAP1 Nerve2 pathway via intrinsically reactive metabolites. Not only did this work demonstrate that mitochondria report on their metabolic status to the cell's antioxidant system, but it changed the paradigm for understanding how this pathway works. She showed that KEAP1 can sense electrophilic chemicals not only by sensor cysteines, but also by a conserved lysine residue as well. And so her work will undoubtedly help us better target this target for intervening in disease, and it has told us something truly fundamental about how the cell can talk to itself using chemical messages. Next month, Laura will be joining Belhara Therapeutics, where she will continue her career in developing new medicines. Our loss is very much Belhara's gain, as anyone who has ever interacted with Laura will attest to the really true personal warmth she exudes and the very much unbridled enthusiasm she brings to every interaction that she has. Today, she's joined by her family, including her mother and her inspiration for doing science, Mia, as well as her father, Hannah, her 2 sisters, Sarah and Rania, her aunt and her cousin. Congratulations, Laura. We are very proud of you.
Good morning. I'm Benjamin Cravat, a professor in the Department of Chemistry. It's my great pleasure to introduce Alex Reed. Alex received his undergraduate degree in biology from Cal Poly and San Luis Obispo. Following graduation, he entered the biotechnology industry here in San Diego and worked at a local company called Abide Therapeutics, where he was introduced to the fields of chemical biology, neurobiology, and helped to discover some of the first endocannabinoid hydrolase inhibitors that have entered clinical development. As a co-founder and advisor to Abide, I had the pleasure of getting to know Alex during that time, and I was delighted when he decided to join Scripps Research as a member of our group in our graduate program. Alex's thesis work focused on mapping and on the mapping and chemical inhibition of enzymes involved in regulating a key class of bioactive lipids called the polyunsaturated phospholipids, which serve many functions, including as precursors to signaling molecules and as a source for toxic oxidative products that drive an atypical form of cell death called ferroptosis. His studies have taken Alex on a fascinating journey through the fields of high-throughput screening, enzymology, mass spectrometry-based proteomics, modern structural predictions, and cancer cell biology. At each step of the way, Alex showed an admirable appetite for tackling new conceptual and technical challenges with creativity, tenacity, and scientific rigor. He's also one of the most collaborative members of our group, always willing to help others with their research challenges. And as I've personally gotten older, I've come to value certain rare traits in individuals, and one of them is dependability. And I can say without question that Alex is one of the most reliable individuals with whom I've ever had the pleasure of interacting. He's truly a rock to which others grasp onto and enjoy benefits that far exceed what he personally achieves, and we're really grateful for that. So Alex will next join an exciting local startup company as one of its first scientists, where I'm certain he will play a major role in creating transformative medicines for our future. Today he is joined by his parents, Bruce and Vicky, his wife Hannah, and their daughter Sienna. Alex, my warmest congratulations on this incredible and well-deserved accomplishment.
Hello, my name's Ashok Dennis. It's my distinct pleasure today to introduce Emily Bentley, who is here. Emily received her BA in biochemistry from Case Western University. She then joined the Scripps graduate program, and we were fortunate enough to have her join our lab. For her PhD research, Emily mainly worked on a transcription factor protein, CREB. So this protein is very important in regulation of many biological activities and processes, such as metabolic regulation, neural plasticity, and memory, and also viral infection. And so it's also an important therapeutic target for various diseases, including Alzheimer's disease and diabetes. So also this protein is a member of this very cool family of proteins that are shapeshifters. And actually their shape-shifting is very important for function very often. But obviously, as you can imagine, very difficult to actually look at and examine how they work. So for this purpose, Emily actually used state-of-the-art single molecule approaches where you can zoom in on individual proteins and watch them moving around and interact with other partners and function. So using these methods, Emily actually did some beautiful research, and overall her work showed that the protein and its interactions with DNA, which is very important for function, is a very complex interplay of binding to partner and also changing shape. So this work actually also opened the doors to future work, both basic and potentially therapeutic. So I'll also say I really like this aspect of her research. Emily really dug into the mathematics of the problem. So there's a whole chapter on mathematics in her thesis for understanding this problem. So definitely worth looking at. So with that, I'll just say Emily is now pursuing a long-term passion of hers, which science writing, really enjoying working on this aspect in Jeff Kelly's lab. So big congratulations, Emily. I'm really proud of your accomplishments.
Good morning, everyone. My name is Kiri Engel. I'm a professor in the chemistry department, and it is my immense pleasure to congratulate 4 outstanding recent graduates from my group, one of whom, Elena Vasquez, is graduating today in absentia, and the other 3 of whom you'll see parading in front of you on stage here this morning. The first is Taeho Kang. Taeho came to the Scripps graduate program after completing a distinguished undergraduate degree at KAIST, essentially the equivalent of MIT or Caltech in Korea, and also after completing his service in the South Korean military. As an undergrad, Taeho published 2 papers in the fields of natural product total synthesis with Professor Sun-Kyu Han, and prior to graduate school had already earned a prestigious Kwangjeon International Fellowship, which is reserved for only the most outstanding students from Korea. Taeho came to my group to study organometallic catalysis, and true to his military background, quickly proved himself to possess a superhuman work ethic and to be a human Swiss Army knife as a researcher. He made important discoveries in palladium, nickel, and copper catalysis with accomplishments so impressive and wide-ranging they could have constituted 3 PhD theses. But you only get one today, Taeho, sorry. One of the main highlights was that Taeho developed a reagent tuning strategy that allows 3-component couplings to be performed to assemble bioactive, medicinally relevant compounds in a single step, and this has quickly become a favorite of collaborators working in medicinal chemistry in the pharmaceutical industry. After completing his PhD a few months ago, Taeho is now currently pursuing a postdoc at Cornell University in the area of polymer chemistry with 2 leaders in the field, Professor Jeff Coates and Professor Yandong Wang. Taeho, if you know him, you'll know he is a man of few words and few emotions, but a man with a big heart. And beyond his achievements in the lab, he is an incredibly dedicated mentor, and I think one of his most impressive achievements to me is that essentially for his entire graduate career, he has mentored 2 high school students, both who came to the lab as 16-year-old neophyte researchers, neophyte scientists. and left the lab with co-authored papers under Tejo's mentorship, one of whom is now at Yale and the other of whom is starting at MIT in the fall. Tejo, I'm incredibly proud of you, and congratulations on your accomplishments. Next up is Ziqi Li. Ziqi began her education at Nankai University, training under one of the legends of organometallic catalysis, Professor Qiling Zhou. During this time, she also spent a highly productive period, first as a visiting student at UC Berkeley, and then later here at Scripps Research under the mentorship of our colleague, Professor Jinquan Yu. Ziqi had already published 9 papers somehow before enrolling in graduate school, so I had a very serious responsibility as an advisor, which was to stay out of her way and not mess her up too badly. In my lab, she continued this incredible pace, amassing a wonderful body of research that pushed the frontiers of carbon-carbon and carbon heteroatom bond formation using earth-abundant metal catalysts, as disclosed in 17 papers, with 2 more still to go, which she kindly reminded me of yesterday. Her stellar achievements earned her a prestigious BMS graduate fellowship and the opportunity to now pursue a postdoc with Nobel laureate Professor Francis Arnold at Caltech. Outside of research, one thing that I miss about Ziqi is her unfailingly kind and considerate nature. She would regularly bring us homemade baked goods and fresh fruit and make sure that we were keeping our bellies full in the lab. But then one day, I think she realized she had overdone it because I came in and I saw that she had brought me a treadmill. That's a true story. But thank you for everything you've done for me and for the lab, Ziqi, and for keeping me healthy during your time in the group. Congratulations. Lucas Oxtoby. Luke is a native of Wisconsin whose accomplishments and exciting trajectory were evident from a young age. He was an Eagle Scout and graduated as a straight-A student from UW-Madison, earned an NSF graduate research fellowship, and published undergraduate papers both in the field of organometallic catalysis with Jen Schumacher and in the area of chemical education. And in my group, somewhat to my sadness, Luke graduated in near record time, just over 4 years. And despite this short period of time, Luke developed a solution to a problem that had vexed chemist after chemist in my lab for nearly 4 years. He developed a co-catalytic transient directing group strategy that obviates the need for stoichiometric auxiliaries that we had used to enable reactions that were of interest to our lab. And this innovation allows for reduced step count and waste generation, directly in line with the goals of green chemistry and sustainable synthesis. Luke's findings opened up an entirely new research direction in my group, which continues actively to this day, and we were able to pull him aside for some free consulting just yesterday with some of the team members who are still working on this project. Luke's research was recognized with several awards and honors during graduate school, including selection as an AbbVie Scholar and an award from the International Precious Metals Institute. Luke is currently working as a process chemist at Sterling Pharma Solutions, not too far from his hometown in Germantown, Wisconsin. And during graduate school, I came to know Luke pretty well because for a period of time we were carpool buddies. And Luke taught me a lot. One thing I learned from Luke is that the human body can be sustained on an all peanut butter diet for much longer than one might expect. And if you're interested in detailed, in-depth analysis of different peanut butter brands and whether you should be using crunchy or smooth for meeting your nutritional needs, Luke is the man to ask. Luke, thanks for everything that you've accomplished in the lab. Thanks for everything you've done for the lab and accomplished during your time as a graduate student. I'm really proud of you, and congratulations.
All right, hello everybody. It's my distinct pleasure to introduce Tim Bishop. His title was his thesis was titled "Probing Acetyllysine Writer and Reader Function in Acute Myeloid Leukemia." And Tim graduated from NYU, where he worked for a couple of years studying transcription, the process of turning genes on and off in certain tissues. And so he came to my group in 2018 with similar interests applied to chemical biology. And he came to our group when the group consisted of just me and another rotation student, Yu Sheng, who we'll talk about in a moment. The two are sort of inextricably linked in my mind. And Tim joined the lab when I was not even a tenure track professor, just a Scripps fellow with a 3-year appointment. So he either thought he was going to have a very quick PhD, or he had more confidence in our research program than I did. His productivity was remarkable, especially when you consider the circumstances, having to really build the lab from the ground up. And so he left our lab with 2 first author publications, one in ACS Central Science and another in Nature Chemical Biology, which just came out a couple weeks ago. His work revealed really fundamental insights into the pharmacology of Yates domain, which is a sort of emerging class of drug targets, and as well as insights into the biology of ENL, which is an emerging leukemia target. And then in separate work, he revealed a class-wide mechanism of resistance to clinical stage anti-cancer drugs that target proteins called acetyltransferases. And I'm confident that work will be instrumental as those compounds advance further into human clinical trials. He's now working with Dan Bachevchin at Sloan Kettering, where he'll continue to stretch out his legs in chemical biology, and I'm very excited for him there. Tim, congrats on everything you've accomplished, and thank you for everything you've done for our group. Next up is Leopold Garner-Wurzel. His title, the title of his thesis is Pharmacological Modulation of ENL AF9 Yates domains, highlights a diverse role for ENL in cancer biology. Leo graduated from the University of Pittsburgh and then began his PhD studies here with Floyd Romsberg. And so he came to my laboratory in late 2019, which you might recognize as being just a few months before the COVID shutdown. So Leo has faced really unexpected circumstances and incredible adversity in completing his PhD studies. And so it makes his accomplishments even more impressive in my mind. I first met Leo when I was teaching in the Chemical Biology 1 class, and he was the exact student you want to have. 95% of students stare at you like, will you please stop talking? And Leo was always very engaged, quick with answers to questions, and has a really sort of broad and encyclopedic knowledge of things. So I was very excited when he came to our group and put that knowledge to quick use. Today he earns his PhD with a first author paper in ACS Central Science, where together with Tim, we reported and characterized the first biologically active chemical tools that could inhibit or degrade this new leukemia drug target, ENL. We're very excited to see where his work leads in clinical translation in the future, and he leaves us with a real treasure chest of preliminary data to understand the basic function of those proteins. So congrats, Leo, on everything you've accomplished, and thank you. Okay, last on the list, but the first student to ever join my group beat Tim by just a hair, Yusheng Zheng. His thesis is titled Collateral Lethality Between HDAC1 and HDAC2 Exploits Cancer-Specific Nerd Complex Vulnerabilities. Yusheng graduated from Hong Kong Baptist and then earned a master's from the Imperial College of London before rotating in my lab in just the beginning of 2018, I think it was. And he was the very first student to do this. I think he first knocked on Ben's door, and then Ben pointed him in my direction, and much to my shock at the time, he agreed to rotate with us. And then he just sort of rotated for like 6 months without ever making a decision of whether he had joined the lab or not. I guess he did. But he was certainly taking a major risk in doing this, and it was much to my benefit. I think it paid off quite beautifully for both of us. Actually, Yusheng made a joke in his defense that, what did you say? You didn't know how much risk you were, I didn't know how much risk I was taking when I brought you into the group, but in fairness, you didn't know how much risk you were taking on. Yeah. That was my thoughts at the time. So he has a manuscript describing a suite of new drug targets for genetically defined and incurable neuroblastoma and lymphoid malignancies that will be published probably in the next month or so. It's been accepted at Nature Structural and Molecular Biology, and it's a really fantastic work and an enormous amount of data that really shows his productivity and work ethic that he had in the lab. He's nursed a sort of budding interest in bioinformatics during his time in my group, much of this sort of self-taught. And I guess he became so impressive in this that Genentech just hired him into their Discovery Oncology group to be a pure bioinformatician. A really amazing jump and quite a brave one that I'm impressed by. He also continues to wrap up collaborative work with our lab that I think is some of the most exciting stuff that he's been involved with, and will ensure that you are never rid of me. So congrats, Yusheng, on the very bright future, and thank you for everything.
Hi, I'm Olivier George. I'm a professor in the Department of Psychiatry at the University of California, San Diego. And today I have the privilege of introducing a young woman whose tenacity, talent, and passion for learning and research have really left a profound mark on me and everybody in my laboratory. Kokila is a Penn State graduate student. She got a bachelor in biology, and she joined Scripps Research in 2017, when she became a Kellogg Fellow and joined my laboratory when I was at Scripps at the time. Luckily and unluckily for her, as soon as she joined the lab, I had to move the lab to UCSD. I promised her it will last a couple of weeks of trouble, but it took about a year and a half for the lab to reopen. And despite all this struggle and the pandemic at the time, she continued her hard work. She persisted. She showed tremendous resilience and collegiality, and really flourished in the lab. So today she stands here with a remarkable record of honors and awards. She has 9 publications, which is 3 times more than what I had at her stage, which is not too bad. Kokila's area of focus has been the neurobiological mechanism underlying the effect of nicotine on feeding behavior. It has been really long accepted that nicotine always decreases feeding, but Kokila really challenged this dogma. And she made really a paradigm-shifting discovery that shows that, contrary to what everybody was thinking, the initial time when nicotine enters the brain actually increases feeding. So this paradoxical mechanism was never described before, and she used a multidisciplinary approach to demonstrate the biological mechanism underlying it, including hormonal changes, neuronal changes, and metabolic changes. So I'm really proud of the work that you have done, because I think you're opening by yourself an entire new field of studies. Very excited to see what will come out after that. Our achievements do not end in the lab. Kokila is really passionate about teaching, mentoring. She has mentored countless number of high school students and college students. She has been also a leader at Scripps, as the Vice President of Advocacy, Vice President of Communication, and finally the President of the Graduate Student Council. And despite all this responsibility and duties in the lab, she managed to become also an expert in science policy and advocacy and science communication through 2 programs at UC Irvine and UCSD. And after all that is done, she's not over yet, and she decided to become a competitive ballroom dancer, just because she has so much time on her hand. And since we are all wearing gowns, perhaps you should show us some tricks at some point and teach me, your mentee, something new. Kokila, I'm very proud of your work. You have touched the entire lab, and we're going to miss you. Please join me in congratulating Kokila.
Hi, it's a great pleasure for me to introduce Valentine Kurobla. Valentine came to our laboratory as an experienced biochemist, and during her time in the lab actually emerged as an exceptional mass spectroscopist and chemical biologist. And Val has made significant contributions to the field of structural proteomics. Her commitment to teamwork has been invaluable to the lab, fostering a supportive and collaborative environment. And as a result of that, Val has really become the most reliable person in the lab and has taken on the responsibility of mentoring all the new students coming into the lab, as well as postdocs coming into the laboratory. Val's determination to solve complex problems is evident from her studies on the nuclear receptor LRH1, showcasing her creativity in applying chemoproteomic approaches, which resulted in the identification of a novel co-regulator of LRH1, which is the subject of a first author paper that's currently in preparation. During the pandemic, Val took the lead on collaborative efforts with Eddie Arnold's lab at Rutgers, resulting in 2 first author papers, one in Science Advances that provide valuable insights into the dynamics and organization of SARS-CoV-2 non-structural proteins. Val also contributed to 6 additional papers, highlighting her dedication to scientific collaboration. Outside of the lab, Val is known for her competitive spirit in sports, particularly volleyball, and her commitment to community service. As an example, she was president of the Grad Council. Although Val will be missed in the lab, I'm excited to see her grow into an exceptional independent scientist. I'm sure she'll be very successful at whatever she chooses to proceed, but Val will at the moment will continue her postdoctoral research in my laboratory as she plans her career path, which will include pursuing an academic postdoc and then eventually transitioning into industry. So Val, congratulations on all your achievements.
Good morning, everyone. Congratulations to the graduates this year and their families. I'm Howard Hang, a professor in the immunology department here at Scripps Research, and I'm pleased to present Stephen Klepp with his PhD thesis. My laboratory studies how bacteria in your gut promote intestinal health in response to cancer immunotherapy. And previously, we had discovered a particular bacterial species and an enzyme that promotes intestinal health and response to cancer therapy. But we had a major challenge in the lab, which we had never characterized whether the enzyme was essential for the function of the bacterium or essential for modulating host immunity. And this is a challenge that Stephen took up when he joined my laboratory. And Stephen was able to make a very key mutant in this enzyme, in this gene in this bacterium, and showed that it was essential for the bacterium to divide properly and also be essential for its ability to promote host immunity. And this is a major challenge for us for several years, and this is, I think, a major accomplishment that Stephen undertook in my group. And I want to thank him for his contributions to the group and congratulate him for his PhD thesis. So, Stephen.
Good morning. I'm Jeff Kelly in chemistry, and it's a privilege today to celebrate Nicholas Yan's PhD. His dad and his mom are here with us today. So my lab is interested in diseases where protein conformational or shape changes lead to misassembly and destruction of tissues that don't easily regenerate. One of these diseases is particularly complex because first and foremost, it's a cancer. So the cells that make antibodies proliferate without making the heavy chain, and they secrete a form of a protein that can then undergo a shape change and aggregate and destroy various organ systems. Now, when we started this project, it wasn't even clear that there was a small molecule binding site on these so-called light chains. And in collaboration with Ian Wilson's lab, we came up with a screen. And Nick, through his incredible talents in structural biology and small molecule design, revealed that there was, in fact, a binding site, synthesized or orchestrated the synthesis over 1,000 small molecules. And in a few weeks, we should be in a position to select the clinical candidate that we're going to do a clinical trial with in this disease. So, Nick, I think it's not an overstatement to say that you're a force of nature. You've been an incredible contributor both in Ian Wilson's lab and in my lab. And Nick's going up to UCSF to work with the Southworth and Gaswicki labs, where he's going to learn how to apply electron microscopy to structure-based drug design. And I have no question that we'll be seeing Nick's name in the headlines many, many times in the future. Congratulations.
Good morning. My name is Ian McCrae. I'm a professor in the Department of Structural and Computational Biology, and it's my pleasure to introduce Melissa Parker. So I had the privilege of serving on Melissa's thesis committee for the past 5 years, so this meant I was able to witness the growth of and learning into this spectacular young scientist, and also witness firsthand all the amazing discoveries she made in the field of ribosome biogenesis, which of course is central to life as we know it. I also was routinely it's weird. I was also routinely inspired, actually, by the depth of thought and rigor in Melissa's science, as well as the genuine caring and passion she brought to her work, and to always look forward to her meetings. Sadly, Katrine Karpstein, Melissa's advisor, can't be here. Katrine and I have I've known her for a long time, and so I know that Katrine is very excited about Melissa and very proud of the work she's done and the scientist she's become. She gave me a few words she asked me to read. So these are Katrine's words. I'm so sad to miss this exciting day that honors our great students, in particular Melissa, who's contributed to my lab in more ways than I can count. Her graduate work has led to 3 first author publications, and we are about to send the 4th one out for revision. This last one, the latest finding, has opened an entirely new area for my lab and for the ribosome field. However, Melissa has done so much more. She's been a thoughtful presence in my lab meetings, whose contributions I miss. Her science communication skills are outstanding, being reflected in multiple poster awards, and also the fact that she was highly sought after by fellow students in and out of my lab when preparing a presentation. She's also been on the Graduate Student Council for years, volunteered for countless outreach and philanthropy events, and she's also taught courses for the summer undergraduates and a science communication course. Congratulations on an exceptional thesis. I miss you. Congratulations.
So it's my pleasure to welcome Blessy Suresh to the stage. So I'm going to be saying some words on behalf of her advisor, Matthew Disney, who is not able to join us due to travel, but I have some words that he sent to me. So he says, I'm sorry I couldn't be there to celebrate Blessy's commencement, but I want to express my thankfulness to Blessy. It was a great joy to see her develop as a scientist and tackle some very difficult scientific challenges. Developing a framework for targeting mRNAs with small molecules aimed at therapeutic development. This resulted in 3 high-quality first author papers. In the lab, Blessy has a very uncanny ability to steadily make progress on her science, doing it in a quiet and determined manner with thoughtfulness and rigor in her experiments. As she was well liked in the lab for these and other qualities, being a solid team member and supportive of other graduate students and trainees. We're looking forward to her continuing to have a positive impact on the world through her science. Blessy will continue her scientific journey in her new position as a scientist at Arrakis Therapeutics in Boston, I believe. Right? Yep. And we wish her all the best. Congratulations. Next student I'm pleased to introduce is Sarah Mosier. So I'm going to be reading comments on behalf of Douglas Coteen and Laura Soltz, both of whom weren't able to make it today, but they sent some words along for you, Sarah. So Sarah is one of those rare students who choose to perform joint thesis work in the labs of Drs. Laura Soltz and Doug Coteen, fully embracing the multidisciplinary nature of our graduate program. She successfully achieved her goal, marrying her interest in structural biology, specifically exploring how ligand regulation affected a family of transcription factors, nuclear receptors, at the structural level, and extending this knowledge to a better understanding of nuclear receptor transcriptional activity in mammalian physiology and disease. While in the Soltz and Coteen labs, Sarah established a strong track record in peer-reviewed publications, serving as a first author on 3 manuscripts, co-author on 7 other manuscripts, and authoring 4 reviews and commentaries. She was awarded a NIH Ruth Kirstein F31 Award and received many other awards and accolades during her tenure as a student at Scripps, including the American Association of Immunologists Young Investigators Award and a D. Shaw Graduate and Postdoc Women's Fellowship. Outside of the lab, Sarah has been very active in the community, extending her love for animals by volunteering at various animal shelters and venting her scientific frustrations through Brazilian Jiu-Jitsu tournaments, medaling in several of the tournaments that she competed in. And as a side note, I'll say that Laura tells me she's only mildly afraid of you, Sarah. So. While she will be missed in the Florida community, she will not be straying far from her roots and will soon be joining Atheon Therapeutics, recruited by none other than our own former Associate Dean, Christoph Rader. So good choice, Christoph. Congratulations to Sarah on job well done, and we're sure today will be only the first of many proud moments and successful moments for you to come. Congratulations. Okay, so the next student I'm going to be introducing is Mai Tran. And so this is on behalf of Michael Farzan, who wasn't able to make it today. So Mike also sent me some words. And so Mike says, Mai has everything necessary to make an exceptional scientist: brains, creativity, talent, and drive. She demonstrated this clearly in her thesis defense, where she identified and then improved Cas12a CRISPR ortholog with higher efficiency and a distinct PAM recognition region. The content of her first author publication also supports this, and her forthcoming work describing how to edit B cells without CRISPR or any nuclease at all. However, her amazing talents extend beyond the lab. She's an accomplished pianist, something we were treated to, sometimes we were treated to Debussy echoing through Building C late at night. She's also an accomplished watercolorist, and her food is amazing. And here's a parenthetical side note. So according to Mike Farzan, she makes the best homemade peach ice cream ever. So something to recommend. And then also she's an expert mixologist specializing in exotic drinks that were very much appreciated and a big hit with the Farzan lab. So beyond these abilities, she has shown something even more important than talent or determination. It's guts, moxie, fearlessness, or whatever you want to call it. It's why every step she has taken has been a big one. It's probably what allowed her to travel half a way around the world to get her undergraduate education in the U.S. and to do so well in college that they put her picture in the Birmingham airport. And I never had time to ask Mike exactly about that, but you'll have to, maybe at lunch, you can tell me about that. And thankfully drew the attention of our admissions committee. So where her courage really shows is in her exceptional willingness to take on hard, high-risk, potentially high-reward projects and see them through. So this again brings us back to her work editing B cells without CRISPR or any other potentially harmful nuclease. She could have taken a much easier project, but she wanted to have an impact. So this work will harvest a nice paper and potentially valuable patent for the University of Florida for her courage. Mai is continuing her postdoctoral work as a fellow at Harvard Medical School in the Farzan lab. Mike says Mai has everything it takes to be a great scientist, and therefore I'm very proud to see Mai Wong Tran as a new doctor of philosophy from Scripps. Okay, so the next student up is Yiming Yin, also from the Farzan Lab. And so Mike says, Yiming is the most powerful combination of intellect, talent, and drive that her mentor, Mike, has ever seen in a graduate student, or really in anyone, perhaps some of his most accomplished senior colleagues. As he said in her defense, it has been an absolute thrill to listen to her reason, to see her navigate through the data and watch her interpretations develop by leaps and bounds as she develops as a scientist. Also to see this raw talent turning into an extremely promising scientist. The work of her thesis started with a novel in vitro evolution strategy using CRISPR and B cells published in PNAS, and then move it rapidly in parallel to in vivo evolution approach that she could use to affinity mature mouse human antibody from CRISPR edited primary B cells. This work will be published in a forthcoming Nature Biomedical Engineering paper. The work of both of these manuscripts are all hers, and this is now the basis for several additional PhD projects in the lab, and the source of 2 new NIH awards, and the basis for a number of collaborations, on which Yiming is a central contributor. It'll be an absolute thrill to watch her develop into an independent, original, and highly successful academic scientist. Yiming is continuing her postdoctoral work as a fellow at Harvard Medical School in the Farzan Laboratory, and we look forward to great science coming out of from Yiming's future work. So congratulations.
There he is. My name is Christoph Rader, formerly from the Jupiter, Florida campus of Scripps Research, where this fantastic graduate program is continuing to thrive. I'm here to introduce my final PhD student, Matthew Sear, originally from St. Louis, Missouri, who defended last summer shortly after joined Arrowhead Pharmaceuticals in Madison, Wisconsin. Despite the pandemic and other hardship he faced personally, Matt's rigorous, resourceful, and undeterred approach to science allowed him to complete his PhD on time in 5 years, funded by an NIH fellowship and resulting in 2 beautiful first author papers, 2 patent applications, and numerous other contributions to my lab, the Institute, and the program. And if this weren't enough, Matt and his wife, Allie, who is here with us today, became parents twice during his PhD. As the closing picture of my academic career, I needed Matt to win this game, and he sure delivered. His studies centered on antibody drug and target discovery for cancer immunotherapy. He built and extensively probed T-cell engaging bispecific antibodies to a new target on chronic lymphocytic leukemia cells. He also conceptualized and validated a new antibody-driven antigen discovery strategy that led to several new target candidates on multiple myeloma cells. A top talent with a sophisticated skill set, Matt could have joined many biotech and pharma companies on the East or West Coast, but always true to himself, he wanted to return to the Midwest where his journey began. Let me also take the opportunity to thank his Bicoastal Thesis Advisory Committee, Jim Paulson, Matthew Pipkin, and Travis Young, for their superb guidance. Congratulations, Matt, you're awesome. So speaking of thesis advisory committees, I was on one that was quite entertaining at all three levels, mentee, mentor, and topic. I'm happy to introduce to you the mentee, Alyssa Shepard, with the words of her mentor, my friend Joe Kissel, who unfortunately can't be here due to his son's coinciding high school commencement. So here's what he sent me. It is my honor and pleasure to present Dr. Alyssa Shepard. There are several qualities Alyssa possesses that make her a joy to work with. First, she is tenacious. She almost single-handedly developed the tools and methods required for establishing a novel in vivo model of cancer using a non-traditional organism, the naked mole rat. These are challenges she faces on a daily basis and is able to deliver solutions consistently. Second, Alyssa is super smart and efficient. From very early on in her graduate career, Alyssa was able to troubleshoot and identify solutions independently. I recall a discussion we had during her first year in the lab when she described an experimental approach she designed to assess efficiency of CRISPR-based editing, including all the required controls. I was impressed. This was at a level I would have expected from a senior graduate student, and Alyssa was already there. Third, Alyssa is a real team player, always eager to help others and train new people joining the lab. I could go on and on about how great Alyssa is, but will stop here for lack of time. However, one thing about Alyssa that I still find challenging to figure out is her decision-making process when it comes to the color hair she will decide to show up with. I'm not at the graduation, but if I had to guess today, her hair is the shade of red. So thank you, Alyssa, for sticking with this challenging project, and I look forward to seeing this in print soon.
I am Erica Ullman Sapphire, a Scripps PhD alumna myself, and a member of the immunology and structural biology communities here for 25 years. I have the distinct honor today of introducing to you Dr. Jingru Feng. Dr. Feng began her bachelor's degree at China Pharmaceutical University in Nanjing, the capital city for 6 dynasties. From there, she earned a master's degree at Johns Hopkins, where she began studying emerging infectious disease. She began full-time research after that at the University of Texas Medical Branch at the Galveston National Lab, where she worked on the inner workings of the Ebola virus. From that point, she knew what she wanted to do for her graduate career, and she joined Scripps Research. Now, I first met Jingru myself right after her arrival when we were in a seminar in the Beckman Auditorium. And at the end of the seminar, the audience asked questions. And I heard in the back of the room a young voice whose question exhibited such penetrating insight that I had to see who had asked it. And we had a conversation right after that at the Flame of Knowledge. And after speaking to Jingru, I said, would you please join my lab? And I've been honored to work with you ever since. In her research, she pioneered new techniques and new avenues, forging new ways forward and creating biochemical and biophysical firsts for an entire order of viruses. She studied the polymerases of Ebola virus and Lassa fever virus, proteins that others have not purified or been able to analyze before. She did proteomic techniques to learn how they hijacked human proteins for their own purposes. And then she progressed further, looking at how they gather the molecules needed for replication by phase-phase separation, by liquid crystalline organization, by which they also hide themselves from your innate immune signaling. And she continued with pioneering in situ tomography to actually study the structures by which these replication processes happen inside the cells. As I assumed greater leadership responsibilities, Jingru really shone. She mentored students. She led collaborations. She developed new techniques by herself. And it's very clear to everyone that worked with her that who is standing before us is a future professor. On behalf of her Scripps co-advisor, my colleague and friend, Juan Carlos de la Torre, congratulations, Jingru. We have been so thrilled to see all you have discovered and all that remains for you to reveal for the world. Congratulations.
My name is Ryan Shenvey. I'm a professor in the Department of Chemistry, and I am immensely proud to introduce Dr. Tucker Magnus Carlson Huffman. Not actually his middle name, but we'll get to that. Some knowing laughs here have anticipated it. Tucker entered our program after acing the rigorous chemical biology major at Berkeley with an unbelievable 4.0 GPA, despite a 3.3 average within that already high-tier major. He excelled in undergraduate research in Dan Nomura's group and knocked the socks off of Scripps alum Professor Tom Maimoni, who ranked Tucker as, quote, off scale. Tucker's exceptional performance continued in our graduate program, where he continued to pull down all A's and garner multiple prestigious fellowships, including an NSF GRFP, extremely hard to get, and an ARCS fellowship. He was the first student in my group to conceive of his own research project and proceed to execute it and publish it in a top journal, Angevete Chemie, which just surpassed Jack's actually for impact factor. Tucker, thank you for letting me be on your paper. All this, plus he served as TA for 2 classes, lectured for a 3rd, published another paper in a different top journal, and yes, even had his first child, although I'm gonna give Danielle more credit for that one. During his time in graduate school, Tucker always impressed me as a person of character. So I was surprised that when research took a downturn, Tucker developed a powerful addiction to online chess. Now, if I've learned anything from Dan Kahneman and M. Scott Peck's books on psychology, it's sometimes hard to identify your strengths, but it's even harder to identify your weaknesses, self-evaluate, and correct course. So I was very impressed that Tucker staged his own intervention and gave the lab permission to verbally and physically separate him from chess.com. As a result, he did make significant project on a project of great importance to my lab and the biomedical community at large. Tucker's 3rd thesis chapter helped establish a platform to study, characterize, and optimize a small molecule that decreases levels of c-Myc in chronic myeloid leukemia cells by an unknown mechanism. In this final flourish of graduate school, Tucker laid the groundwork for some very important research in the coming years. Tucker is joined today by his mom and dad, Lori and Frank, mother-in-law Angel, and family friend Kathy, friends Daniel, Brian, and Ruth, and of course, his wife Danielle, and the guest of honor, his 1-year-old son, Harvey. After defending his PhD last year, Tucker caught the San Diego biotech bug and spent a year at Ferring Pharmaceuticals before moving to Neomorph, an exciting local protein degrader company. Tucker, I'm proud of what you achieved during graduate school, and I'm thrilled to see what your future holds. Congratulations.
Hi, my name is Seth Tomczyk, and it's my distinct honor today to introduce and congratulate Valentina Val-Botero. Val joined our lab and focused her dissertation research on the role of the NF1 gene and its encoded protein, neurofibromin, on the neuronal control of metabolism. This gene, when it's mutated, it causes the genetic disorder neurofibromatosis 1, which impacts behavior and systemic physiology in multiple ways. Her research really unraveled how loss of function in this gene impacts the cells, the molecular function downstream of the NF1 gene, and the systems that underlie metabolic regulation in NF1. She was highly accomplished during her period in her dissertation research, publishing 4 research papers already, with actually 3 more on the way. I actually had trouble keeping track and miscounted in her dissertation defense, with another review potentially on the way as well. She was funded with an F-31 award that she obtained herself, as well as an initial research fellowship that she obtained before even joining the lab. Her work seeded research that ended up forming new avenues of research within our lab. And so she actually had to start new collaborations across multiple labs to push this project forward, which really highlights some of the interpersonal skills and scientific leadership abilities that she has and that she continued to develop as her dissertation progressed. It was amazing working with her during her dissertation. She's exceptionally intelligent. She's intellectually curious, hardworking, and just a great person to be around. And so her impact is revealed through both her scientific accomplishments and the impact on the people that had the privilege of working with her, which I'm happy to include myself in. And so she also was generous with her time and service and developed these leadership skills through, just to name a few, she helps teach TAing 4 courses at Scripps and doing community outreach at the community, mentoring at the community college level and in Diverge Scripps events to spread our impact beyond our physical walls and natural intellectual boundaries. So I'm awed and inspired by what you've been able to accomplish, Val, and I am thrilled to be able to congratulate you today and to introduce, for the first time in a professional setting, Dr. Valentina Botero.
Good morning. My name is Jamie Williamson. I'm a professor in the Disco Bio Department, and it's my privilege to introduce my student, Ann So. Ann had her thesis in 2 parts. She was a student in the laboratory of Floyd Rumsberg, where she undertook fundamental studies in non-natural base pairs, trying to understand how they were translated in human cells, and also trying to understand how they withstood the process of reverse transcription. When Floyd left Scripps, Ann transferred to my laboratory, where she took out a completely independent project studying the assembly of HIV on a lipid membrane. This is a joint project with David Miller using single molecule studies, but Ann was the first to develop a biochemically defined system for the interaction of the HIV GAG protein, which is the major capsid assembly protein, in the presence of a lipid bilayer. She did both single molecule fluorescence studies and employed a brand new technique known as mass photometry. So this was a really interesting new application using mass photometry to look at an RNA and a protein binding on a lipid membrane. She elucidated the earliest stages of viral assembly and answered the long-standing question of how packaging of the viral genome occurs at the membrane. So Ann, everything about this project was difficult. Everything was a new technique, everything was a new obstacle, and through her brilliance and dedication, she was able to overcome this. So she has 2 publications from her non-natural base pair work, and we're working on a really nice publication on the most recent study on virus assembly. Now, Ann has an entourage here, so I'm pleased to note her parents are here, And I would note that her father is a professor at Nankai University in chemistry. She's also joined by her partner, Jan. Okay. Everybody's got their own pronoun, okay. And Jan's mother is here. And I would note, so Jan, maybe many of you know, is a graduate of our program. And he worked for Professor Jingquan Yu. And it turns out this is, in fact, the second couple that has emerged to get married, one from my lab and one from Jingquan's lab. And so if you don't know the layout, our labs are right around the corner, and there's this apparently magical water fountain where people seem to meet. But Jingquan and I have decided that we're going to initiate a joint program. And so one of the features of this program is graduation on Friday and marriage on Saturday. So we're really pleased that Anne and Jan are having a ceremony tomorrow. Congratulations.
Hello, my name is Luke Wiseman, and I'm a professor in the Department of Molecular Medicine, and I have the pleasure of introducing 3 graduates today. I actually find it very challenging to condense all of the unique experiences these people have in my lab into a short, brief introduction. And it doesn't help that I have a name that starts with W, so I tend to go later when I have to follow everybody else who has still a lot of the good lines. So to sort of help myself along and help you guys understand the unique experiences each has, I've picked movie quotes that I think describes each of their time in my lab. First is Jaleigh. Jaleigh came to us from UCSD, where she crossed the street, and she worked in Jeff Kelly's lab as a technician for a while before she joined my lab as a graduate student. She worked on a project that was really focused on defining the molecular mechanisms responsible for regulating the secretion and aggregation of proteins involved in a class of diseases called amyloid diseases. During her time, she published numerous first author manuscripts in high-profile journals, really revealing new insights into the pathologic and therapeutic implications of endoplasmic reticulum pathways that contribute to the onset and pathogenesis of these different disorders. Her work is now paving the way for small molecule development to intervene in this class of devastating diseases. Now, from my perspective, one of the things that really defined her time in the lab was her expert biochemical skills and her hard-charging attitude. And as I reflected on what quote I'd like to pick for Jaleigh, the thing that really occurred to me is that she didn't really know how to try. She just did stuff. I mean, she was just always doing stuff. So I was really thinking back on Yoda, which actually goes back to Pete's original talk, about how he said, do or do not, there is no try. And that really sort of solidified Jaleigh's experience in my lab. She just does. And I'm really proud of her for everything she did in my lab and everything she accomplished while she was working in my group. I'm sure that she will continue to do as she takes the next stage in her career working at Belhara Therapeutics. Jaleigh, I'm really proud of you and everything you've accomplished. I'm so glad you joined my lab, and I really can't wait to see where you're going to go next. Thank you. Next, we have Val Perea. Val, come on down. Val actually had experience at Scripps before she came to our graduate program. She worked as a surf intern in Katja Lamia's lab. But when she came, she made the decision, for whatever reason, to join my lab, where she was supported by an NSF pre-doctoral fellowship that allowed her to pursue a really challenging project probing the molecular mechanisms by which cells regulate mitochondria in response to pathologic insults. Her work, which is now being published in 2 first author manuscripts that are coming out this year, define new molecular ways in which cells use to adapt the shape of mitochondria in response to endoplasmic reticulum stress, and she identified new pharmacologic opportunities to enhance specific signaling pathways to promote adaptive mitochondrial modeling in human disease. Now, Val's time in the lab really came with a lot of different challenges she faced experimentally. This is a really hard project. I mean, I have to say, I didn't appreciate how hard it was when she took it on. But the thing that really sort of defined her time in the group was how she just would keep going through it. She would keep powering through every single step. And last night, when I was writing this up, the thing that really occurred to me is that reminded me a lot of a character in one of my favorite cartoons, which is Dory, when she said, "Just keep swimming, just keep swimming." That really was what Val was. She just kept going forward and moving forward and taking the next step and just kept going. And really that positive attitude and that sort of I can do anything sort of mentality was what drove her through the graduate program. I am extremely proud of everything Val has done. I have no doubt that she'll continue to swim through whatever next phase she has as she takes on postdoctoral training in a national lab to go on to actually do new and better things. Val, it was really so much fun working with you. Sorry about the project. I didn't realize it was going to be that hard, but you did so much with it, and I really can't thank you enough for everything you accomplished. So, well done. Last but certainly not least is Jessica Rosarda. But by the time I started writing Jessica's introduction, I was really kind of on a roll with the whole quote thing, and it came to me immediately. It was, life is like a box of chocolates. You never know what you're going to get. Jessica's projects all really focused on defining the cytoprotective mechanisms that our compound that was identified in my lab in collaboration with Jeff Kelly's could be used to protect cells against different types of insults. Jessica, using a dizzying array of techniques, Jessica published multiple different papers demonstrating that this compound, called AA147, could protect cells in multiple different ways. This included coordinated regulation of multiple stress pathways to protect neurons from oxidative stress involved in diseases like Alzheimer's or stroke, and the increased secretion of neurotrophic factors that could help protect photoreceptors in the eye from toxic lipids involved in a variety of different diseases like diabetic retinopathy. It's safe to say that each time Jessica started a project, I didn't know what I was going to get. But I also didn't worry about it because I knew Jessica would figure it out. That's kind of what she does. She just figures things out, and she comes and tells me, and she's always right, and it's always been just so much fun to watch her develop and do these things. Apart from her own work, Jessica also has been a real leader in the lab, providing both analytical and experimental support to everyone in my group. Thus, it's not surprising that she's continuing in academia with the ultimate goal of running her own research lab in a national laboratory, which I have no doubt will be successful and worry a little bit about because it'll probably be competing with me for some of the same fundings. That being said, I just absolutely have had such a fun time working with Jessica from the very first time I met her, where she showed up in basically a whole suit outfit, and really came with the NIH mentality that we're able to sort of work together for so long and accomplish so much, and it's just been so much fun. I can't thank you for all the time and effort you've done in the lab. Thank you very much.
Good morning, everyone. I'm Peng Wu from Molecular Medicine. It's my privilege to introduce my student, Zhuo Yang. So I'm so glad today that Dr. Li-Kei Lerner could be here with us to celebrate Zhuo's graduation. So Zhuo got his master's degree from the newly established Shanghai Institute of Advanced Immunochemistry Studies, where his potential in science was spotted immediately by the late Dr. Richard Lerner. For those of you who didn't get a chance to know Richard, he has this rare talent that he can tell if a person has potential or not after he initiated a conversation with you within 10 minutes. So after getting his master's degrees, Joe came to Scripps. I joined Richard's lab at my lab as a joint graduate student. His PhD work was a perfect integration of the antibody technology developed by the Nuller lab at the glycosylation expertise of my lab. He first developed a yeast display-based high-throughput antibody screening platform, using which he was able to discover a high-affinity antibody for TMMAC1, a tumor-specific glycoprotein, and demonstrate its anti-tumor efficacy in mouse tumor models. He then developed a bispecific T-cell engager sialidase platform that can selectively remove sialic acid, a sugar molecule that is highly expressed in tumor cells, as a T-cell tumor cell interface selectively. By this means, he made it possible to extend the use of BiTE for the treatment of solid tumors. Currently, 6 of BiTE molecules have been approved by the FDA, but none of them could be used for treating solid tumors before Joe demonstrated this possibility in mouse tumor models. The paper describing this discovery is coming out soon in Nature Biomedical Engineering. So during the 5 years Joe has been with us, he has been involved in many different projects, and he is also actively participated in training young students. Recently, Joe has got a fantastic job offer from AstraZeneca, and he will be joining their antibody development team in 3 weeks. So Joe, it has been a tremendous pleasure to work with you. I believe that Richard would be very proud of you. Congratulations.
Good morning, everyone. I'm a chemist from the chemistry department. It's my great pleasure to introduce my student, Sean Liu. So Sean was born in one of the most beautiful cities, Qingdao. So as you all know, Qingdao not only produced great talent, but also great beers, right? So, Sean, after high school, Sean was bold enough to travel all the way to North Carolina, Chapel Hill, to pursue chemistry in bachelor's degree, where she really excelled in both classes and the research. So she was highly recommended to us, and we were very lucky to convince her to choose Scripps, and eventually, for me, very lucky to have her in my lab. And in the 5 years her stay in my lab, she's just phenomenal in many ways. First of all, she was just bringing the sunshine to the lab, organize everything, even including the kitchen, and organize all the collaboration with BMS, right? But scientifically, I would highlight, of course, she published Skaggs and Angevante, as the dean mentioned, as a minimum, right? So she published Skaggs and Angevante, every journal, that's top journals. But I would highlight one of her major achievements for drug discovery was to find a new way to make lactan. As you know, beta-lactan, gamma-lactan are very important pharmacophore for drug discovery, but it's very hard to form those rings in a diverse manner because you have to set up the substrate, but in 2 or 3 steps, then form the ring. But it's fine if you have time, you can set up the 2 or 3 steps. But the fundamental problem is whenever you set up an extra step, you're already limiting the chemical space you can accept because every reaction has substrate scope limit. So if you times the 10%, then you end up very limited space. So it's very important to have one step from unlimited substrate scope from very simple aliphatic acid, right? So that's exactly what she achieved. Take simple aliphatic acid, a wide range of diversity, convert them to A by 1 step, and then just cyclize them to lactan, beta, and gamma. So this turns out to be one of the major achievements in collaborating with the BMS and widely used in drug discovery in BMS as well. So following the successful PhD studies, and Sean joined actually BMS as a medicinal chemist now. And actually today, her parents traveled all the way from Qingdao, and actually her husband I think his husband this time, is also here. And he actually worked in Eli Lilly as a medicinal chemist, but he was also my student in the lab. So I think Swan definitely has done doubly well in Scripps, very well. So congratulations, Swan. Let me then introduce my another student, Han So Park. So Han was born in Ulsan in South Korea, one of the top 10 cities in South Korea. He did so well in high school, then was admitted to the #1 university in South Korea called the National Seoul University. And again, he excelled again in classes, and following her bachelor's degree, he won the one of the most prestigious fellowship in South Korea to do PhD. That's called a National President Fellowship. Only the top 5 students in the country can get that fellowship. So really amazing. So we were very lucky. Among many choices he was admitted to, he chose to work in Scripps and end up in my lab. And in his first 3 years, I would say, was quite a bumpy road. He was too ambitious. He had a lot of dream. He dreamed up a lot of great reactions, but it was just not working in the first 3 years. But he was very patient. So he was very patient, continued to design new principle, new concept for ligand design. And eventually, he hit one of the most, I would say, magic ligand and catalyst that allowed him to do a remarkable CH hydroxylation reaction in water and with industrial scale hydrogen peroxide, right? So, of course, he published it again, Skaggs and Gavanti, but as the dean was mentioning impact, I would just mention a few impact this reaction has brought to chemistry. First of all, this large-scale reaction, 300 gram, was run by myself. That's the only reaction I can run in 300 grams by myself in the last 20 years. That tells you how easy, how robust that reaction can run, right? So if you care about watching the YouTube, you can see how when I run the reaction, Han was very cautious, very nervously watching me doing it and ready to rescue me at any point. But I think that nature of him really would take him a long way. The caring and kindness, I think that's an additional quality of Hans that will carry a long way, in my opinion. And if you care to watch the YouTube, that already has like 50,000 views, right, already on the YouTube of me running the reaction with Han. And the second example of the impact, of course, is that also has produced a very interesting hydroxylated compound that actually Jeff Kelly is taking on to exploit for identify new protein, and has already put down a very interesting new protein. And I would say most exciting, one of the future direction probably for that is actually also intrigued a very exciting collaboration, actually kindly sponsored by Tom Daniel, one of the entrepreneurs, as our honor speaker mentioned. Entrepreneurship is very important. So that has allowed us to collaborate with basically Amir Bourgeois to take his ligand into the protein using Peter Show's concept on natural amino acid concept to eventually to perform enzyme, the synthetic enzyme, like perform room temperature in water, large scale hydroxylation reaction. So that's some impact, I think, a real impact. But I think that I would anticipate in the next 3 years, for sure, this will be, Hans' reaction will be scaled up to multiple ton scale for sure. There's no other better way to scale up that CH hydroxylation reaction. Room temperature, I was always joking with Phil. Phil did great using electricity, but I said, now we don't need electricity even. We don't need a heat, right? So, but of course, that's a different context. So I think that when we see that reaction really scale up to ton scale, Hans, we will definitely invite you back to give a lecture to tell the new student your experience. How did you discover that remarkable reaction? So congratulations, Hans. Yeah. Yeah, I should add, he's now a medicinal chemist also in Anta, a biotech in Boston. Yeah, it's a great pleasure then to introduce my third student, Xiaochun Chen. Xiaochun actually was born in Shanghai and then went to the top university, Fudan University, where he did chemistry and was one of the top students in the class. And we were very fortunate to recruit him to Scripps. And he published all the journal, the favorite journal of the dean, Science, Skaggs, Angovanti. He covered all the space, journal space. But I think I would just highlight one work that he did that's really impressive. It just came out in Skaggs. That is, as you all know, the cycloaddition, right, to make a ring structure or cycloaddition is very important to make a ring structure for drug discovery. And that has already won 3 Nobel Prizes. Since Diels-Alder won, Woodward-Hoffman won, and then, of course, Scripps won, right, for the cycloaddition reactions. And all of them use pi orbital. So the dream of one of our major campaign is one day, can we get rid of the double bond, just use single bond, and then stitch all the CH bond and make ring structures, fuse ring, spiral ring, whatever you name it for drug discovery. And that's hard, but I think the recent paper came out in Skaggs by Xiaochun just demonstrated, indeed, that's possible. You can take adiabatic acid and motor cleave the CH bond, just zip them up. You can make a bridge a very complicated ring structure topology for chemical space for drug discovery containing nitrogen as well recently. And that impact, again, already started an amazing collaboration with Ben to exploit this incredible ABPP program for proteomics to pull down new proteins, right, for drug discovery. So that's going to be very exciting, just the beginning of that concept. And I think together with Ben already eluded the new company we started. So hopefully we will exploit that technology in a very big way in the near future to bring benefit, real benefit to humankind. So congratulations, Xiaochun. And Xiaochun now is in Inside as a medicinal chemist. So congratulations, Xiaochun.
It's now my pleasure to confer the doctoral degree upon the candidates. Will all candidates please rise? By the authority vested in me by the Board of Trustees of the Scripps Research Institute, and on the recommendation of the faculty of the Skaggs Graduate School in Chemical and Biological Sciences, I hereby confer upon each of you the degree of Doctor of Philosophy. Graduates, please move your tassels to the left side of your mortarboards, and will everyone join me in congratulating them? You can be seated. A little bit of advice. If ever you want to get in a reservation in a restaurant, use doctor in front of your name, okay? So, one of the greatest pleasures I have as president of Scripps is the ability to confer honorary degrees. These are usually given to people who have had a major impact on the scientific enterprise, and in this case, it's someone who's part of the Scripps family. And I only see one person on the stage without a hood. So, John? As I said, John has degrees from Princeton and Stanford, but I thought it was about time we gave him a real degree. Okay. John, by virtue of the authority vested in me by the Board of Trustees of the Scripps Research Institute, I confer upon you the degree of Doctor of Science honoris causa, which admits you to all the rights and privileges of this degree. This concludes the conferral of degrees. The new degree recipients, their family and friends, the faculty, students, and guests are cordially invited to a luncheon right outside of the auditorium. Audience, please remain at your seats, and the ceremony will now conclude with a recessional. Thank you.